here we are talking about the Bohr model for the hydrogen atom. And in this section, our goals are to be able to describe the Bohr model. That would be helpful if the section title is called the Bohr model for the hydrogen atom. And then explain the meaning of quantized energy levels in an atom, and show how these levels relate to the discrete lines of the spectrum of an atom. And then finally be able to distinguish between the ground state and excited state. Okay, so Bohr model for the hydrogen atom, what do we mean by that? Well, in 1913, Niels Bohr, a Danish scientist, proposed what is now called the Bohr model for the hydrogen atom. And that's shown over here. And here's kind of the takeaways from this. An atom consists of a dense nucleus containing all of the atom's positive charge and nearly all of its mass. Okay, so this is the nucleus of the hydrogen atom. It's a proton. All right. Negatively charged electrons of very small mass travel in orbits around the nucleus. And the orbits are huge compared to the nucleus. And we've, I believe, seen this picture before. So here's an example of an electron traveling, kind of orbiting around the nucleus, kind of like a moon would orbit around a planet, okay? And most of the atom is empty space. We saw that in another video. So Bohr reasoned that the energy possessed by electrons in a hydrogen, or I should say electron, hydrogen only has one electron. So by the electron in a hydrogen atom and the radii of its orbit are quantized. Okay, so what does that mean? Well, it means that at any instant, the electron may have one of several possible energies, but at no time can it have an energy in between them. We're going to talk about what that means in a second. But before talking about it as it relates to an atom, let's talk about it as it relates to this young lady who's going to the chemistry lab. So we can see here over on the left, there's a ramp to get up to the chemistry lab, right? So she can continuously walk up the ramp. So that's what we mean by continuous. And in the case of energy, it's just a continuous spectrum. Whereas if something is quantized, there's discrete steps. Okay, so in this case, there's now steps to get to the chemistry lab that she's walking up. And so each step is on a different level. That's what we mean by being quantized. So now if we go back to the Bohr model, here's the Bohr model for the hydrogen atom, the electron in hydrogen. So let me just draw a little electron here. So let's say he's right there, not to scale, okay? The electron is normally found in its ground state, and it is only can circle around the nuclei or the nucleus at certain radii and with certain energies, okay? So each one of these rings here is a different distance away from the nuclei, obviously, and it also corresponds to a different energy, and that's something we're going to talk about in a later video. So it can't exist in between the electron. It's got to be at one level or the other level. There's no in between here, okay? And like I said, an electron is normally found in its ground state, which is the condition where the electron in an atom occupy the lowest possible energy level. So for the single electron in hydrogen, this is the n equals 1 level. And we're going to, again, talk about that coming up in a second. So here's where the electron resides most of the time. So if the atom absorbs energy, then the electron can be raised to an excited state, or the electron can be promoted to one of these other energy levels, okay? So pretty much all the time, or we could basically just say all of the time, the electron is in the lowest energy level, but then given enough energy, it could pop up to an excited state. So what does that look like? It looks something like this. So on the bottom here, we have an electron in its ground state, n equals 1 for hydrogen. It absorbs some energy, gets promoted up to an excited state, and then it's not up there for long. It comes back down, and when it does, it emits a photon. Okay, the energy is released in the form of a photon. So then the energy of this photon is quantized. Again, it corresponds to the line spectrum of each element, and it has to do with the the specific energy level you're at, okay? So you're gonna get different lines for these different energy levels. So here we go. So this is the different lines here. Each one of these lines corresponds to a different energy level for the hydrogen atom, okay? And so the orbits in the Bohr model of the hydrogen atom are called principal energy levels, or principal quantum numbers, that we use the symbol N when we talk about them. And for example, you've already seen this in the slides. N here is equal to 1, N is equal to 2, this is N is equal to 5 up here. Each one of these is a different level or a different step, okay, in the energies that the electron can have in the hydrogen atom, okay? But again, most of the time, or pretty much all the time, it's gonna be in the N equals 1 level, the ground state, unless it's given energy to be promoted to an excited state. So I hope that's clear, and we're gonna be talking about more examples as we go through. But this is kind of the idea that each one of these levels is like steps, and when you excite an electron up there, when it comes back down, it emits some light in the form of a photon, and that light is what gives you the line spectrum for that element. So in the next video, we're going to be talking about the quantum mechanical model. It's a tongue twister of the atom, and we're going to try to bring some of these concepts together. See you there.